Second problem on ladder friction. So in this problem, a uniform ladder of 4 meter long weighs 200 Newton. It is placed against a wall making an angle 60 degrees with a floor as shown in the figure. So this is the figure is given. So it makes an angle 60 degrees with respect to the floor. The ladder is 4 meter long and 200 Newton is given. So 200 Newton it has to be applied at the middle of that 4 meter. So this is at this, and the coefficient of friction between the wall and the ladder between here at this point it is given as 0.25, and the between that of ground and the ladder is 0.35. So at point A it is given as 0.35. Next, the ladder, in addition to its own weight, has to support a man 1000 Newton at the top B. So the man is at this top B point. So the weight is of the man is given as 1000 Newton. So you have to calculate the horizontal force P to be applied to the ladder at the ground level to prevent slipping. So due to this man weight and this 200 Newton, the ladder slips this side. So therefore you have to apply a force P here. So what is that force you have to calculate? And that is first part of the problem. In second part of the problem is what it is given. If P is not applied, if the P at this point is not applied, then what should be the minimum inclination of the ladder with horizontal? So now you have to assume this 60 degree, instead of 60 degree you have to assume it as theta, and you have to solve. Okay, not slip and at the top. Okay, so now we'll start with first case 1. Case 1 means we have to solve for the horizontal force P, what should be applied at point A. Okay, so now this is the free body diagram. This is the ladder weight. So here the length of the ladder is 4 meter and the weight of the ladder is 200 Newton. It should be applied at the exactly at the middle of the ladder, that is at the 2 meter, and this angle is given as 60 degrees, and the man weight is 1000 Newton, which is he is at the top of the ladder. Okay, so now to solve this you have to apply. So here since the ladder slips to the left side, the frictional force will be there at the right side, that is I have taken as FF, that frictional force at floor level. So and therefore frictional force is equals to mu into normal reaction. This is normal reaction NF. So mu into NF. So mu F is nothing but frictional force level at the rake level, and this is mu F. So the mu F is given as, see, that is the friction force between the ground and ladder is given as 0.35. So therefore this becomes 0.35 NF. Okay, so then next one more is, since the ladder goes down, so therefore frictional force should be upwards. So that I have taken as actually this should be FW. So this is FW is equals to mu W into NW, that is 0.25 NW, is because this value is given as 0.25. So this is the figure. So and here you have to, since this ladder slips this side, so you have to apply a horizontal force P to stop this ladder. So you have to find out what is this force P has to be done. Next, so therefore to solve this, first thing is you have three equations, that is summation of H equals 0, summation of M is equal to 0, and summation of V is equal to 0. So which equation you have to take first, you have to remember. See, since you have P is unknown, see if you have P unknown, see if you take H equals 0, you cannot solve anything. And if you take summation of V is equal to 0, in summation of V is equal to 0, we have NF and 0.25 NW is unknown. So therefore it is not possible to solve at this. So therefore first what we'll take is, we'll take moment about A. If you take moment about A is equal to 0, if you take moment about this, so these three forces becomes 0. So then you have to solve for this. In this we have unknown is NW. So therefore we'll take moment about A is equal to 0. When you take moment about A is equal to 0, first 200 into 200, for taking moment about 200 we need this horizontal distance. This horizontal distance is, this is given as 60 and this is 2 meters. So therefore this distance will be 2 cos 60. Next is plus, and this produces clockwise moment, so therefore plus, and 1000, the distance from here to here is 4 cos 60, that is also clockwise, so 1000 4 cos 60, and this one, this force is going up, but it produces anti-clockwise moment about A. So anti-clockwise moment, that is 0.25 NW into this distance is once again 4 cos 60. So this is 4 cos 60, and this is NW. This NW into this distance, that is 4 sine 60 is equal to 0. So in this whole equation, NW is the unknown, so therefore we'll get NW. So one thing you have to take precaution is, if you don't substitute these things 0.25, 0.35, NF, NW, so it will be little bit difficult to solve. So therefore at the first stages only you make this arrangement. So next is this is summation of V is equal to 0. If we take summation of V is equal to 0, so sum of vertical forces, if we take sum of vertical forces, means what are there? NF is there, and this is 0.25 NW is there. So NF upwards positive plus 0.25 NW upwards. Next, minus 200 minus 1000 is equal to 0. So therefore NF is equals to, from the, because we know NW, so NF is equal to, you'll get 1061.25 Newton, you will get it. Next, when you take summation of H equals 0, in summation of H equals to 0 means P is going right side positive, plus 0.35 NF is there, minus NW is there. So in this NF and NW values we know, if you substitute that, we'll get the P value. So this is the case 1. Next, in case 2, what it is given means you have to take P is not there, and instead of 60 you have to take it as theta. So case 2 is the horizontal force is not there and theta is unknown. Okay, so first thing is, if you take summation of H equal to 0, so what is summation of H equal to 0? So that is 0.35 NF minus NW is equal to 0. Therefore NW is equal to 0.35 NF, we will get it. So now if you take a summation of V is equal to 0, when you take summation of V is equal to 0, NF plus 0.25 NW minus 200 minus 1000 is equal to 0. So therefore NF will get it as, this equation turns to be, NW is known here, so substitute that and we'll get it NF as 1301. So from this, if you substitute, go back here, you will get NW. So NW will get as 0.35 into NF, so you'll get it as 386.20 Newton. So this is how we will solve. So we got NF and NW, so both are unknowns we have solved. So next we have to solve theta. So if it's solved to solve theta A, if you take moment about A is equal to 0, so what is moment about A? 200 into this horizontal distance, 2 cos theta, and 1000 into 4 cos theta, and minus 0.25 NW into 4 cos theta, because this is produces anti-clockwise, and minus NW, this is NW anti-clockwise, into 4 sin theta is equals to 0. So therefore in this whole equation NW is there, so NW value we got it already, so substitute NW values, so we'll get it equation in terms of sine and cos, and if you'll get it 4013.8 cos theta minus 444.8 sin theta is equal to 0. Therefore tan theta is equals to, we'll get this value. So tan inverse of that, if you take, you will get the theta value as 68.95 degrees.